Hello everyone, today we're going to talk about angles and like the theory. Is theory even spelled correctly? Yeah, it is. So the first thing that we're going to talk about is the complementary and supplementary angles. So first, let's discuss the complementary angles. So let me just. So complementary angles, it's when like so basically the complementary angles, it's when like two angles with the sum of 90 degrees. So basically complementary, they form a right angle. And an example of this is easily shown. So over here, A and B equal 90 degrees. And just an example, I guess, of a question, which is easy, however, still. 70x, so work out what is x. Well, x plus 70 is 90, so take away 70, x is 20. Yes, straight isn't spelled, is it? Straight line. So supplementary angles are when basically two angles with a sum of 180, so form a straight angle. So here we have a line and angles, so B and then A plus B equals 180. And so another, let's say we have something like this, and we need to find x. Well, we know this, so take away 70 from both sides, x equals 110. So, sum of angles in polygons. First of all, I want to quickly, well, I personally wasn't 100% sure what a polygon is, if that makes sense. So, and if I show it like this, so polygons are something like this. Basically, a square can be one, but I'm not sure how to define them, but like basically things that are able to have angles, I guess. However, like, yeah. So, oh, why am I going on YouTube? And for example, over there we saw there was a triangle. Sum of angles in a triangle will always be 180. So just know that. Like, so let's say we have this type of triangle, and what's happening here is all of these add up to 180. So an example could be having a triangle. So these all add up to 180. So we have to take away these. So that will be 145. So x is equal to 35. So that would be, yeah. And then so basically, let me just actually get polygon. So we have A, B, C, D, E. All of this equals 5 minus 2, take away 108. So that would be 3 times 108. So that would be 540. So all of these equal to 540 degrees. And another example of this can easily be, let's say we have went like this. So we have 90, 90, 98, x, 95, 56. All of these numbers equal to 4 take away 2, which is 2, and then that's times 100, so 360. So we are able to count these three and take away from this to find x, and from that we know that x will equal 111. And a very important note is that and what I mean by this is, let's say we have a triangle, right, and there are some outside kind of I'm thinking how to draw it. Okay, like this, and like this. So let's say, yeah, that, so exterior angles are the ones that are outside, and all of this equals to 360. These, not the ones, they don't count the ones inside, they count only the ones outside, and that will always be like here. For example, it can have be like this, and it will be 360. I mean, probably not like this. It has to be like specific, but I'm not really sure. But most likely it is in any way. What I saw. Let me check what is this spelling.
Must know no.
So, isosceles triangle theorem. So the rule is if two sides of a triangle are congruent, then the two side angles opposite those sides are also congruent. So the same, basically. Congruent is the same. So let's say these lines means these are the same. They have the same length, right? And so these angles will be the same to each other. They'll be equal. So let's say B, A, C. A to B is equal to C and B. This is equal to this is equal to this. And in that case, if that's the case, then A will equal to C. So, like the angle. I could write it small ones. So let's say we have an example, right? Find X. So we see they are the same numbers. So we know this is also 35. So, and we know that triangles add up to 180. These two add up to 70, so X is 110. So, after that we have, exterior. So, the exterior angle theorem is basically like, by exterior angles, I mean like the ones outside, right? So, let's say, something like this. So this is C, this is A, this is B, right? And we have the exterior one, right? So the exterior angle of the triangle, of our triangle, is equal to the sum of the two opposite interior angles. So not this one, the opposites. So these two are opposite this one. So what it says is D equals to A plus B. And the reason this works is because, first of all, we can use the... Wait. Actually, yeah, we can. So, first of all, this rule that tells us that these two are the same, right? But see, we still kind of have safe, like, space there. And for that, in that case, the other thing is that this rule, like, if it was perfectly aligned, that would create the full D angle. So that's why it works. And not only that, but also the line equals to 180 and the whole triangle equals to 180. And so, since, like, how can I explain? So you know how A plus B plus C equal 180? Same B plus C equals 180. So it's only C that's always the same. So these, they're the same number because they give the same result. So that's kind of the mentality behind it. And so let's say we have an example. So let's say we have 110. Let's say we have X and then 40 here. From this, we're able to tell. So it seems like we don't kind of have enough. So you might think, oh, this is a 90-degree. No. Stop right there. It's not 90-degree because if it was, then this would not add up to 180. So wait. We're able to find it by, again, it would be 70 because that's what creates 180. After that, we add these up to, and like, that will be 110, take away, so this one is also 70. Yeah. So that's how this one works. Now, let's say vertical angle theorem or theory, forget. When two lines intersect, so intersect means connect basically, like this, the angles opposite each other are equal. So A, B, C, D, or D. So A equals B, C equals D. Done, like, it's easy. And the example is X and 61. What is X equal to? Well, it's opposite 61, so 61. Pardon me. So alternate angles are basically about if two parallel lines are cut by a transversal. There are two stuff that basically about the so what I mean by this transversal is so for the interior one, let's say we have the lines and it is cut, right? They're parallel lines, again don't forget parallel. So we have A, B, C, D. We can do a Z, and we will see a, well, let's not choose yellow. We will do a Z, and we can see that A equals D. We can do other Z and see that B equals C. So that's how it works for the interior. Interior, again, is what's inside. For the exterior, again, same kind of principle, all right? Parallel lines, blah, 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 but all outside. Again, we can do this time, we can also do the F. However, the F is for kind of a different one, I guess. But you can also do, again, Z. This one is equal to this. F equals H. E equals H, and that's not H, that's G. So, yeah. And the example is find X and Y. So Y is here, X is here, and there's 110 here. Well, from this we can already tell that again, if we use our Z method, we will see that these two, they are parallel. Like A, so look, A and D, here. It seems confusing because it seems like X should be parallel to this one, but no. It's just how maths works and like all that type of stuff. Like if you were to flip it or whatsoever, you would see kind of better, I guess. So X is 110, and this is a 180-degree line, so Y is 70. So co-interior angles is all about like the interior angles. If they're on the same side of a transversal, they add to 180. So what I mean by this is, we have a line, right? We have a cut, like where the transversal basically a cut. We have two angles. So angles on the same side of a transversal cut. So they're on the same side, and they both equal 180. Like, no, they don't both equal, they add up to 180. And the way it works is most likely because they kind of usually would form 90 degrees, because a straight line and like a straight line kind of sort of makes that thing. However, yeah, but the examples find x and well, it's the same thing, it's just turned, so 75, x equals 75. And then so corresponding angles, like the rules, angles which occupy the same relative position at the same intersection are equal. So what I mean by this is, again, we do these two lines and A, B, C, D, E, F, G, H. So A and E are equal. B, basically, if they're in the same position, right, they're equal. So yeah, the example is find x and x 41. Well, they're in the same position, but x is 41. Now, so what I mean, so in scripted angles, subtended, that's a T, subtended by the same arc are equal. So let's say we have a circle, and the arc length is here, we can do any point here, right? Like, for example, and put it like this, and then let's say this one over here, and we put it like this. The angles over here, A, B, they will be equal to each other. And however, after that, these two, they will also be equal together, I assume. I assume that they will be because they're opposite each other. And then these, the way you can find these is by adding these two, like, you know, all this maths, 180, blah, 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 take away. And so, but in this topic, we have another rule, rule 2. So let's say we have a semicircle. No matter where the thing is, you put it on the, like, you connect them with the edges, it will be a 90. It guarantees you that. And so the example is, we have a circle, okay. Circle, arc length is here. This, y, 65. What is y? Well, plus, like, come on, guys, 2 plus 2. What's 2 plus 2? The answer is 65, because, come on, like I just said, that they're equal. Like, if they're connected by the same arc length, so they're equal. After that, the last thing is angle at center versus circumference. So basically, the rule says that the angle subtended. I'll just show you instead of talking it. So you have a circle, right? In the circles there is this center, right? And the arc length is here. So you do the connection, right? And then you just do another connection right here. Well, basically the rule says, like, exactly at the same points as the arc, this angle here is going to be double this one, like the one that's in the middle. And if they're connected at the same, like literally at the same, this is x, this is 2x basically, because it's double. So an example of this, so let's say a very dumb circle, but imagine it's a proper circle. The arc length is here, this is x, this is 142. What's x? Well, divide this by 42 because it was a double of this, so 121. That's it. Goodbye.